Recording has begun. Let's get started. I want to talk about SQL. So, SQL, like, what does that mean, right? It stands for Structured Query Language. Structure, right? It's like there's a protocol, there's a set of steps, there's a format to how we ask questions, query, that we are asking questions, and this is like the way that we're going to do it. This implies that there is something to ask questions to, right? So we use SQL to ask questions to a database. What's a database? It's like a file that has tables and rows, right? So we could like make some comparisons to things that we've done, right? We could say that like in the whole course of a Ruby app, we have like the whole database, and we could say that there's like a Ruby class in our Ruby app, right? And that could be the same as like a table in a database. And then we'd have a Ruby instance of a class, right? One member of a given class, going down one step in scope. Following this pattern, who can tell me what would correspond in database land to a Ruby instance? If the whole app is the file, if a class is a table, what is an instance? So we have a database file. In the file, we've got some tables. We might have a table called like tweets, right? And this would be like a table, and you can tell because like look, that's how tables start, with like a name and then a line. And like we might say that like each of these has like an ID, right? And then also has a message, and then also maybe like refers to a user. We used to just say user in Ruby land. Now what we might do is something slightly different. We might just say user ID here instead. And then we'd have various tweets, right? So like the first tweet might have ID of 1, and the message here would say like coffee with a trailing hashtag, and then the user ID might be 1, because we might also have a table that's called users that might also have an ID and a username. And that would mean that like user 1 would have the username of coffee dad, right? And therefore, like this first tweet with a message of coffee would belong to user 1, and then we'd have user with ID of 1. So when I think about an instance of an object, I could represent as a class, right? This feels like the tweet class, because this would contain the instructions, right, for what it means to be a tweet. We could think about like a second tweet as belonging to maybe a second user, right? We could have a second user who's named Matcha Mom to kind of keep up with this example that we had from before. And we'd have a tweet here by Matcha Mom, right, where the message could be about matcha, the user ID of 2. And then perhaps we have a third tweet that exists in the database where we say, like, love my coffee, and that's once again by Coffee Dad, right? So maybe I bring this over a little bit just to make it clear what column is what, something like that. Sure. So what I'm trying to do is kind of show that we had things like user and tweet before. We had one-to-many relationships before. These are still useful things to us. They're not going anywhere. We're just going to find new ways to model those existing relationships. Instead of a tweet object holding an entire user instance, now we're going to have it hold on to what's called the primary key, which in a database refers to the number at the beginning of a given table row that indicates like this is this row's fingerprint. No other row can have this identifying number. That's why ID, right? So by pointing to user ID of 1, we can see that there's 2 tweets belonging to Coffee Dad, and with pointing to user ID of 2, we can see that there's 1 tweet belonging to Matcha Mom. So coming back to this example, right? If the whole file is like the consisting of these 2 tables, that would be like having one big app, right, where a user can post tweets. And so one whole class in Ruby might be like the users table or the tweets table. And so I'd say an instance here. Anybody figured it out yet? What part of this or what scope of this might refer to one exact instance of a Ruby class? A row, absolutely. One of these horizontals, right, with a given ID and some other attributes, will refer to like kind of one to one with a Ruby instance. So we'd say table row here. And then in terms of an instance variable, right, that's like one spot in a row, like knowing the user ID of a tweet or knowing the message of a tweet. So I'd say that an instance variable is similar to like a cell, right? I won't repeat my terms here. We'll say table, row, and cell. So when we talk about SQL, what we're really interested in doing is taking things that we already care about in our code, things that we've already put into our model domain, concepts that we know that we want to track data around, and we've taken that stuff and we've put it into a database, into a table in some formal way so that that file can maintain, it can hold info. Now, this, I can't read a DB file. This is chinook.db. If you open the zip file that I sent out on the Slack, you should see this here as well. And it's not going to display right in the editor. I can try to open this anyway. It warns me I'm not going to see much. And I'm looking at like, this is like, okay, it's got extensions, and I don't know if I will even want to read this right here, because you're not supposed to edit a DB file in place. I can see some stuff. I see Black Sabbath. I see I plays Metallica by Four Cellos. I see some integer primary key auto increment. We see varchar. People who have worked with SQL before will recognize varchar as kind of a stand-in for what we know as a string. I see some data here. I don't feel safe touching any of this. I feel like if I add so much as a space character into this file, I might break how this actual database is being read. The database is not intended to be read and written directly in a file like this, right? If we want to get into a database, we use other tools, and those other tools under the hood are using SQL to talk to the database. So if I'm curious about all of the names of tables, that's a command that I can use on a database. If I'm interested in all of the rows in a given table, if I want to add a row, if I want to add a column, a new thing for a row to have, say if I want to add a whole new table, right? So there's all these questions we can ask to a database. Let's talk about types of questions. We could say like that there are kind of meta queries, right? Which is about, let's say, create a table, create a column, things that like get things started, right? We'd say that that's like a meta type of question to ask. I have a question to ask this database about the state of the database itself. And then we also have like kind of create type queries, which would be about like adding rows to a table. We'd also have read type queries, which would be about retrieving data from tables, right? Questions designed to get info back. We'd also have what's known as update queries, right? Which might be about modifying existing rows. What's another thing that we can do to information that we haven't discussed in this list so far? We can create stuff, we can add stuff basically to the database, we can read stuff that's already there. Yeah, we can update and change things, or we can delete things, right? There aren't really that many other things I can think to do. In fact, I think this kind of encompasses all of the things that we could potentially do with data. So all the things that we'd want to do with data, including setting up data that we could do these things with, right? I'd put meta like in parentheses here. There's definitely stuff for it. But when we talk as developers, we talk about CRUD all the time. When we talk about CRUD functionality for a resource, we mean that our application lets a resource be created, read, updated, or destroyed, right? And that means in the context of our Ruby code, I would like to not just have a class called to-do list, right, that has many to-do items, right? I would like to also have a database where I don't have to go and make a new to-do list every time I start my Ruby application, which defeats the whole purpose of a list, right? The purpose of a list is I write it down and then it stays there and it knows stuff that I don't have to know again. I don't have to recreate it every time I go back and look at the list. So persistence is a very important concept. To manage persistence, we need to be aware of all the different things we can do with the data that we've persisted. And so we have some exercises here to work with a real database and to kind of get decent at working with using Google to like look some stuff up maybe. I want to use all of our tools at our disposal to start writing some SQL code to solve these challenges. So first of all, this Chinook DB, I think it's been compiled by Microsoft originally for like educational and testing purposes. This is not where I want to read a database file like this. Instead, I want to use the database browser that I downloaded from that SQLite browser. It's called DB Browser for SQLite on my computer. If you don't have that installed yet, it's not too late. It only takes a couple of minutes to do, and it's pretty straightforward. But what I like about this is that unlike having to use the SQLite gem or the SQLite 3 gem on my computer, there's a bunch of labs that go through working through those commands, and you might find that missing a single semicolon or using a double quoted string instead of a single quoted string can really stymie your efforts and slow you down. I like a tool like this because it gives me a nice clean UI and kind of a smooth entry into my data if I'm just trying to understand it and test out some queries. So I'm going to click here to open a database, and then somewhere in here I've got our folder. I have to find it. I've got so many things. Let's see, there's Flatiron. And here's us. Intro to SQL. Cool. I find my DB file, I open it up. And so just a quick tour through how this works. We have 4 tabs across the top. I'm not really that concerned with the 3rd tab. This is almost like a debug mode for my database right now. I'm not that concerned with that. I am concerned with database structure because it tells me what tables exist in my database. Looks like information is stored about albums. Each album has a title and an artist ID and an ID. Also storing a name and an ID for artists. All of these things have IDs, right? We call IDs primary keys. Now these down here don't, and this is because these are like more meta tables that SQLite uses to keep track of its own-ish, so to speak. But we come down to tracks and we have a conventional table here. It looks like track might be the main unit of data that we care about in this database because so much granular information is stored here. I would almost imagine if I had an online music store that this might be the kind of information that I'd want to know. And notice here that there are some implicit references to other tables. I say implicit references because we have these fields that end in underscore ID, and then the first thing before the underscore matches up with the singular name of some other table. So genre ID seems like whatever value is here might correspond to the ID field under genres. Album ID seems like it's designed to correspond to the ID field under albums. And indeed, this is the design, as we'll see as we go looking through some of this data. We call this a foreign key, and we'd call this a primary key in this relationship. And we'd say also that just like how a tweet had the user stored on it, right? The thing that belongs is going to hold the foreign key for the thing that has. So I know that because each track belongs to one genre, that a genre has many tracks. And that makes sense as I say it out loud. There's multiple rock songs in the world, right? An album also has many tracks. That makes sense. This is a 10-track album, right? And we'd also say that since albums have artist ID, that an artist has many albums. So by using this database structure tab, I can start to comprehend not just what models might exist, but what relationships might exist between those models in my model domain. If I go into browse data, I can really test this stuff out, right? If I go down to the tracks level, I have this nice little drop down to hop between tables. And I go and find like a song that I know like maybe what album it came from. So I don't know, like Let There Be Rock by AC/DC. It says that this is associated with album ID number 4. So I then go to the albums table and I look for album ID number 4. Haha, that is Let There Be Rock. Like, what a better sign that I found the right track for the right album. I managed to land on the title track. Spoiler alert, I'm actually not an AC/DC fan. I'm just an extraordinarily good guesser, and I lucked the F out on that one. So let's move past it before I lose my streak. We have execute SQL, right? So if I'm tired of just looking at data here and just looking at structure here, and I want to see if I can actually run some queries against this data, this is a working window for SQL. And here we can explore what some basic verbs are as we go through these challenges kind of in sequence, and we'll learn more verbs and more like modifying like conditional statements and things like that to get our SQL queries more and more precise about the things we want to do, not just with our data, but to the database itself. So coming back here and looking at this README, the first challenge, The first challenge says, write the SQL to return all of the rows in the artist table. So if I'm going to role play very, very briefly as somebody who's just doing my first SQL coding today, I'm going to start letting today be a day that maybe I will let Google do some heavy lifting for me. SQL is a very, very common tool. Whatever language you write in, if you store stuff in a database with that language, you're going to have to interact with SQL, right? Not Python's version of SQL, but SQL is SQL. Python might work with a SQL database, Node might work with a SQL database, Ruby might work with a SQL database. It's a very universal problem space. So I don't need to think of myself as a unique and privileged Flatiron School student as I read this question. I can think of myself as just a coder, just a bland beginner who needs to figure some stuff out the same as many other people. So I see right here all of the rows in the artist table, and I go, well, if I unspecialed this, I would probably just not really worry about the word artist, but all of the rows in the table is what I'd like. So I'm going to go looking for that just by that wording. SQL, all the rows in a table. How to fetch the row count for all tables. So am I supposed to get a table? Or am I supposed to just see all the info? To return all of the rows in the artist table. So I think all of the rows is more than a number. I think they want actual info. How do I select all from a table? This feels right. I'm going to click on this. Basic SQL Server select statement. So I click on this, right? And it talks about SQL Server tutorial. And I get worried because I'm not in SQL Server. I'm in SQLite right now. This is DB Browser for SQLite, right? This intro to SQL is supposed to help us be introduced to the SQLite browser. This is because Ruby uses the SQLite gem. When we work with SQLite, we'll be working with SQLite 3 specifically. And every flavor of SQL is very similar, but they do have some distinct differences. Therefore, if I'm looking at any documentation, I'm going to take it with a grain of salt if it doesn't say SQLite on it. If I want to avoid documentation like that, I could just include SQLite in my Google search. Return all the row information. Maybe I refine my search now that I know that I might be misinterpreted as looking for a count. And now a search jumps right to the top. It's that select thing again. This says SQLite tutorial, so I feel like this syntax is going to be really useful for me off the bat. And it says simple uses of select statement. You can use select to perform a simple calculation. So if we try this, oh, interesting. This has a little select 1 plus 1 execute. Oh, so we have a little browser, another SQLite browser that we found while trying to get our first SQLite browser working. How nice. Querying data from a table using the select statement. We use the select statement to query data from one or more tables. The syntax is as follows. And holy crap, what is all this? Select distinct column list from table list, join table on, join condition, where row filter, order by column, limit count, offset, group by column, having group filter. Whew, it is the most complex statement in SQLite. Luckily, we don't actually need all this stuff, right? I think that we kind of need maybe this and this to get started, right? At its core, select takes some arguments, and the arguments that select takes first are, what do you want me to actually go and get? What do you want to select from the database? And then from lets us narrow our search so that it knows where to go looking for stuff. So what we mean here is that when we go looking for all of the rows in the artist table, we could use some syntax like select. And then what does an artist table have? It has a name and an ID. So I could say select name, comma ID, and name the columns that I'd like. And I could specify the table with the word from, artists. And when I hit play, this will run the SQL query. Now, if I tried to go to arbists, which wouldn't work, right, because it's wrong, I'd get an error, right? No such table, and in my error, I'd get some context of why the thing errored out. Just wanted to point that out, that this is nice because of how it breaks as well as how it works well. When it works well, we can see these results, and we see that there's a counter on the very left of these results that's outside of what I asked for, even before name and ID. It's just keeping a counter, and that's because not every ID is going to be purely sequential in some results that you might get back from a database, and you might want to be able to go and check and make sure that oh, we did get 275 rows returned. But notice here I said name and then ID, and I'm seeing name and then ID. If I switch the order of these, select is going to reorder my output. So select doesn't just tell me what I want to get back, but it tells me how I'd like to get it back. Here's another thing we can do. We could say name as artist name. And notice I've been able to rename the name column according to how I'd like. So select has all these nice little options and tweaks, even at this point, even as we're just talking about the very first argument that we pass in. And SQL is really a game of understanding that we have this very big stringent structure that always has to be ordered in this order. Like I won't always use a where in a SQL query, but if I do use a where, I will always have to use it after any froms and before any group by, right? So this structure is the S in SQL, and the rest of it is the query language itself, the nuances within this structure that let us get the things that we'd like. So I'm just going to say select ID name from artists again. Make sure that that gives us the results that we want. And you know what? We actually have a shorthand here. As Emilio points out, we can just say star, right? And star is a really quick way to say just give me all of the fields, right? And as Dan points out, yeah, select star from songs that slap. Yeah, if we did the same thing, select star from tracks, a little more useful in terms of seeing how nice the star is, because tracks had all those pieces of info, right? And we don't have to list them. I didn't have to say name, comma, genre ID, comma, album ID. Ugh, boring to even say out loud, let alone type. Just star covers all of those things. So select star from artists satisfied our first condition, right? Oh no, I hit enter trying to run it just to make sure before I copy paste it back. But this is one that I'm going to keep. And I'm going to move on to number 2. And this is kind of how the cadence will go for the next half hour or so. We're going to write the SQL to select the artist with the name Black Sabbath. Okay, so we have all these artists, and we see that artist ID 12 has the name Black Sabbath. So we could either select the artist by ID or we could select the artist by name, but something needs to change about this query so that it's not so general. It needs to get more specific. We do still want to see an ID and a name, because if it doesn't tell me like what output it wants, I'm going to assume that the asterisk is the type of output that's going to be fine. Just give me all the rows of the relevant table or tables. But we need to find the one with the name Black Sabbath. So we go here, and we go to, okay, so select, we do have a column list. We're just going to say star. We don't do distinct here. This is kind of like what we did with unique in Ruby. If we ever needed to get unique results from a database, we could say distinct, but I don't really care about those right now. So we're just saying select and then listing our columns with the asterisk from, and then the table list, we only have one table to worry about right now, which is the artist table. So that's what's listed in our query. And then the next piece here is the join. Well, there's not another table to think about, right? So we don't need to think about any condition where more than one table will be played with at the same time. We do need to think about this one, though. Row filter. So out of all of the artist rows that could be returned by this command select star from artists, I would like to use the where keyword to filter my results down. And what's cool about SQL is that I don't need to worry about counting my equal signs. I can just say where name equals Black Sabbath. One thing that's not as cool about SQL, though, is that if I use double quotes for anything, sometimes it thinks I'm talking about a column name, and then it says like no such column Black Sabbath, and I don't like that, so I'm just going to use single quotes to be safe. So I say where name equals Black Sabbath, that works. Like I said, I could have said where ID equals 12. The key thing here is the word where, which gives me the ability to pass in key value pairs, right? Where ID equals 12 and name equals Black Eyed Peas, right? Are there any artists that meet those conditions? There are not, right? I think that there are either or, right? I think there is an artist in here where the name equals Black Eyed Peas. Yeah, it's the one with ID number 169, right? So I can stack different conditions. If I say where name equals Black Eyed Peas and ID equals 169, well, both of those things are true for this row. So we still get this row coming back. So yeah, where can take like multiple conditions, but I'm going to go back on this to where it was when we had Black Sabbath, where name. Yeah, we'll keep that. Moving on to the next one, now that we know a little bit about how select works and a little bit how where can tweak it and narrow us down, we immediately just pivot. We're going to change gears. We're going into the meta zone, right? I would say that either of these would be read kind of things. We want to see information about artists. We want to see information about one artist. Now we're going up above, even adding rows to tables. We're going to create a whole new table in this realm of tables. So how do we create a new table named fans that has something called an auto-incrementing ID that's a primary key, That's a whole thing. And a name field of type text. So this makes sense to me. This is like name and it needs to be a text field. We could think of that as like a string. We could think of that as varchar if we're thinking in database terminology. They're all synonymous. This is a weirder concept. A primary key that auto increments. So primary key is just a special word that says the database thinks of this as the main way that an item should be looked up and cataloged in its tables. And auto incrementing is a really fun concept. Auto incrementing is how, even if your bank has deleted a lot of customers' accounts, your new bank account is never going to accidentally pick up some old customer's negative bank balance and inherit it, right? Because out of all of the IDs that have ever been passed out for a given table, auto incrementing means that no new IDs will ever be included in that original list. If I assign out IDs 1 through 10 and then the user comes and deletes all 10 of those records, the next ID I assign will still be 11 as long as the table wasn't dropped in between that stuff. So auto incrementing is a very nice and important concept to make sure that our data is safe and not accidentally like shared or like bleeds over into other people's possession. So to figure out how this stuff actually gets done, we could go to the Googles and say like SQLite create table syntax. Why not? SQLite query language create table. How helpful. Let's take a look. Ours needs to be called fans. Sometimes you're going to see like a huge diagram like this that basically shows you what is necessary. So here we need to say create table, and then there needs to be a schema name either explicitly or implicitly mentioned. Dot table name will be implicit. We won't have to name our schema. We'll just say create table and table name. And then here we're going to do some column defining, basically defining what columns need to live in that table. There is some, I believe that there's some sample usages. Yeah, in small snippets, right? So like here, create table T, X integer primary key ascending, Y, Z. So yeah, I suppose we could try this out. Um, let's try it out. Create table fans, and then we have to put in parentheses like what our columns are and how they're defined. If I go to the database structure here too, here's a nice thing. In the schema, it also shows the exact command that created these. So if it was hard for you to see like what column def in parentheses was implying, this is a more explicit way to show it, that we have these comma separated pairs where we name the column and then we say what type of thing the column is. So integer primary key auto increment, it's going to be a number, it's going to be the main thing that we look up, and we're never going to reuse the value in any other row in this table after we assign it to a particular row. And then comma, and then we have another field called name, which is a varchar. So that's actually exactly kind of what we're going to do for our fans table creation, right? Name field of type text, well, we'll say name varchar there. Let's start there. Name varchar. And then before the name comes in, we can do an ID, and the ID will have a integer as type, and it will also integer it. It's like Medea's special number. And then it'll be a primary key. Primary key. It's like you're trying to launder a problematic past by opening burger restaurants. You use a primary key to keep track of them. So cool. We have an integer primary key auto increment. And I think that when we run this, we're going to have a new table that has an ID field that is set up to be the primary key that goes up automatically, and we'll have a name field that's a string. Let's see if this works. Syntax error at line 1 near the D. Let's see. ID, integer primary key auto increment. Let's see what we did wrong. Yeah, so they passed this in as like a string, and that might be it. Notice that they didn't use strings here though, right? That like they just said create table artists and then said ID without that being a string. But something about the letter D it did not like at all. And it's only highlighting that when I write it. Maybe it was something that I was holding as I typed the letter, but it's not underlined weird anymore. And now, wouldn't you know it, it just might have been one of those things. Anyways, let's go back and look at the structure and see if we have this table right. It looks like we do have a table fans with an ID and a name, and if we drill down into it and compare it with something similar, like maybe an artist, yeah, these both look okay to me. So this would be a valid SQL in SQLite language, or flavor for creating one of these tables. The only thing I missed on that was I didn't have a semicolon at the end. So the browser was nice enough to not care, but sometimes it'll just wait for you until you add the semicolon, so watch out. Okay, we want to alter the fans table to have an artist ID column type integer. I guess that makes sense, right? If I added myself as a fan, who would we know I'm a fan of if there wasn't some sort of a reference there? And I think this is interesting too that we're kind of implying that a fan is such a strong fan that like when you're in this database as a fan, there's only one artist you're going to be a fan of at a time. So like an artist has many fans, but each fan belongs to that artist that they're a super fan of. A fun concept. Let's model it out just for kicks. So we need to alter this table. We need to add a column to it, which is called artist ID and which is an integer. So I'm going to look for that using SQLite as my Google search. And I'll say add column to a table. Yeah, add column to table. That's what I want. Okay, so there's an alter table statement. I've already been here. I'm going to go over here this time. Alter table statement. You can rename a table or you can add a new column. Well, that's what we not want to do. Alter table existing, rename to. Don't need that. Where's the add a column one? Adding a new column. Okay. Alter table, table name. So alter table fans probably. Let's try that. Alter table fans. Add column. Oh yeah, this is a nice point too. I can add new lines with this, and as long as there's not like a semicolon, like I'm still in the query, so I can have multiple lines as I need to like break up my thoughts and make it easier to read. So yeah, add column, column definition. Add column. And I believe this is going to be exactly the same as what we did before, so I think I can say ID integer, the same way that we defined it as a single unit column definition when we were listing them when we created the table. But this isn't going to be just an ID. I want to call this artist ID. I think that was the goal, right? Artist ID, column type integer. Story checks out. Let's try it out. It says executed successfully. It happens so fast I never believe it, so I always go and check. Yeah, and we have the integer field added for artist ID. So I think that this way we could actually have a fan that references a certain artist, right? Like before, when we looked up the Black Eyed Peas, how did we do that to review? We did a select. We wanted all the info from the artist table. Where, we used where to narrow it down, and then we said where the name of the artist equaled Black Eyed Peas. Let's try this out. This time with a double quote string. Let's see if it finds it. Yeah, it found it that time. So it had no problem using this double quoted string in this context. There's other times where the usage of the string is more, it's hard to implicitly nail down what the intention of the user is, and it usually guesses wrong in those cases when I'm using a double quoted string. In any case, yeah, so this was the alter the fans that we just did, right? Let me go back on that. Paste that in. And yeah, sure enough, we just looked up Black Eyed Peas. We know that their artist ID number 169. So let's add myself as a fan of the Black Eyed Peas. If you're playing along at home, I apologize that I didn't warn you about this, but part of playing along at home means that you must now become a fan of the Black Eyed Peas. I'm not sure if you were ready for that level of commitment. It's happening. Let's get it started. All right, so how are we going to do this? To add myself. So adding myself, this is like a create action, right? This is adding a row into a database that has a table that already exists to hold that row. So let's see, SQLite add row to table. That's what I want to do. Okay, we have this insert into. That seems promising, not just because it's purple and I'm a good meta test taker, but also because insert into feels like if there's a fans table that's supposed to hold on to fan info, I'm trying to insert a new row of fan info into that table. It's taking forever. Oh no. SQLitetutorial.net. Too slow. Is it my whole internet? No, it's not. One person seemed really still, but other people are not very still. So here we are. We're in the insert into. Let's see if we can find an example. Insert into, and then check this out. They say a table name, and then inside the table, they list the column names that they want to add data for. Then they pause, end that parenthesis, and then say values, and pass in the same order the values that fit the column name. So product ID of 1, product name of pancakes, product rate of 75, product quality check is okay, right? And this would end up in the table in this way. So that's what we need to do in this context. We need to insert into fans where the artist ID is 169 and the name is my name. Insert into fans. So we'll say artist ID. The nice thing about having an ID field that has a primary key and auto increments, you don't have to manually set the ID. There might be some labs today that make you manually set an ID, just as an example, so that you can see how tedious it is to have to do. But in general, in a professional database environment, you will never have to manually set an ID on a resource. The database will handle that for us. So I will set an artist ID, and I will set a name for the fan by passing in values in the right order. So the first one would be 169 for the artist ID, and the second one will be Duke. Nice. So that says insert into fans with these values worked, and I could use the browse data tab to check up on that. I could go down here into fans, and yeah, sure enough, we've added Duke, right? If I wanted to make another person a fan of the Black Eyed Peas, we could totally do that. Let's get my brother involved, and my sister as well. I'm sure they'll appreciate it later. Great. So now my whole family is fans of the Black Eyed Peas, and that's taught me a couple things. So let's copy that back. Let's go to the next one. Yeah. So let's play with this. There's a fun little sidetrack. If you hold Option, if you have this open in like VS Code, if you hold Option and click, this should open up the actual link in a browser, and this shows you the documentation for Faker, which is a Ruby gem, a Ruby gem that knows how to fake stuff out. So if you go and like read the first kind of couple code examples here, they ask you to do gem install Faker to install that. So I'm going to do that. Gem install Faker. It doesn't take that long to do. It's not a huge gem. It's mostly a lot of like big hashes, just keys and values and keys and values and keys and values all the way down. And then once you've installed Faker, we could move into like an IRB session from the terminal, and we could require Faker as a string. Once it says true, we know we're in good shape. And then we could call faker name.name or faker internet.email or faker, I don't know, let's find cool names. Let's go to movies. Ghostbusters, Star Wars. I like Star Wars stuff. Faker movies, Star Wars, Call Squadron, character. Oh, that's nice. Yeah, let's try this. Faker movies, Star Wars character. And just like Nellie from The Office getting manager over Andy Bernard, it's just random. And I love it, right? So, like, cool, we'll have Grand Admiral Thrawn be the new name of this Black Eyed Peas fan. So, yeah, how are we going to do this? It says that our goal is to update the table, right? How would I update my name in the fans table to be my new name? Well, let's look at how we update a table in SQLite. We don't need to update the table, though, right? I technically need to update a row, like just my row, right? So there is an update statement. It says first specify the table, then set new values for columns in the set clause, and then third we specify the rows to update using a where clause. Let's find an example of this. So we update the fans table. We're going to set the name to be some new name where, and then we'll have to figure out like what rows in the table we want to set that to be the new name. So it would be like update fans set name equals Grand Admiral Thrawn. Where, oh, how about this? Where artist ID equals 169, right? Any problems with this idea? What could happen here if I ran this query to this data? Yeah, that's right. All of these fans have the same exact artist ID value. So if we ran this SQL, every single fan would end up with a brand new name. Let's actually run this SQL and see if that's true, and then we'll do something better to set things back, right? Now we go and browse our data. Yep, sure enough, all of them had artist ID. What would have been a better condition to set a name? Out of these three, right? Is it where name equals something, where ID equals something, where artist ID? I think we figured out artist ID, and I see ID as a choice. I think ID is always going to be our best choice. If we can get into an ID, that's why it's there. It's there to be the thing that we've been guaranteed is never going to be covering two items at once, right? Because it has that auto increment, the ID will always be one to one with a given resource. If there's no ID in a database, that we know that there's no resource for that ID and so forth. So there, we want to do that. Like, let's set the name to Ben where the ID equals 2. Hit play on that, go browse our data, and that was a nice surgical change. Now we know that Libby needs to go back to being ID 3. Set those straight. Browse our data. Cool, cool. So I would have said here, like, we set our name equals to new name. I'm just going to be vague about the actual value there. It's less important than the other mechanics. And that would be our update row SQL, right? Now here, it wants us to write SQL to return fans that are not fans of the Black Eyed Peas. At this point, I'm kind of like scoffing, but I'm also scrambling. Let's insert a new fan in here that's not a fan of the Black Eyed Peas. Insert into fans, artist ID name, values 100, and this will be Tom Sawyer. Hit play, browse data, great. So we have at least one person who's not a fan of the Black Eyed Peas. Let's make just one more. Values 99 and Jane Goodall. Be a fan of somebody. I don't even know who these artists are, but we'll find out. Maybe. We'll see. So yeah, who's not a fan of the Black Eyed Peas? That's supposed to be our search, right? So we know who is a fan of the Black Eyed Peas based on the fields that points to a given artist. So I think this is going to be our condition for this search. And we'd want to see some fans, right? So now we're back away from creating or updating. We're back into like that reading zone. We just want to return some info about fans. So we go back to using select. We're going to select from the table fans. We're going to get everything from the table fans. But we're only going to do it if you're not a fan of the Black Eyed Peas. So I'll say where artist ID is not equal, and here we can just do the bang equal sign like we might have done in other contexts. And then we just set the value that we want to miss, which would be 169. We run this, and there are our two non-Black Eyed Peas fans that we just added to the database. So that gets us back into the select territory, which feels good. Nice little warm up for the next one. We've only got a few left here with the time that we have. So please do take a moment, and if anybody has any questions about stuff that we've done so far or wanting to see anything else, I'm curious about that too. We don't usually get to all of the bonus stuff, number 10 or 11, so I'm not in too much of a rush. SQL to display an artist's name next to their album title. So here's where I want to kind of pause and maybe go back to what we were thinking about up here. Because we know about this relationship, right? We know that a user has many tweets. We know that a tweet belongs to a user. In here, we're now referring to this primary key notion, setting up foreign keys to have a tweet pointing back to its user, right? So down here with number 8, displaying an artist name next to their album title requires us to know about how artists and albums are structured in this database and what that implies about their relationship to each other so that we can leverage that relationship appropriately. It looks like, based on this table here, artist, right? Nothing refers to an album. If the artist doesn't even have to refer to the other thing, you could think of that as a power move, right? The artist must own those albums because it doesn't have to refer to them at all. Meanwhile, the album, like a child who like needs to know like their home number in case they ever get lost and can't find their way home, the album needs to know about its parents' ID. So an artist has many albums here. An album belongs to one artist. So if we need to show information about every artist, and their album title, that means that we need to somehow get information from both of these tables at once, right? We need an artist name next to the title field from an album. Well, let's start there. Let's just say select title from album or name from artists. So select name, comma, title from artists, comma, albums. Right? It said when we looked up that first query formula, where was that first query structure? Select query. I've lost it, haven't I? Apologies, y'all. The SQLite query structure that we had first looked up had that all of those different modifiers in there. Let me see if I've got it now. I don't have it up here. But it did say that from could take a list of things. So I'm just wondering what comes back if we say, give us the name and title field from artists and albums. Now notice here it gives us 95,150 rows. Why would it give us 995,000 rows if there's only 346 albums and 275 artists? I think that it's because the product of 275 and 346 happens to be 95,150. I think what it's done is it's literally listed every artist name next to every album title. So there, that gives us Jagged Little Pill as recorded by AC/DC, which is nice to think about, right? That gives us Aerosmith playing Mesmerize, which I defy them to try. And then we also have like Alice in Chains playing all of Aerosmith's hits. That sounds like a blast to me. Great. So that's not exactly right. We don't want to just call this as a list. We need to be more specific. So instead of just saying from artists, comma albums, what we could do instead is say from artists, join albums, which now is requiring some other condition. When we use this join keyword, we can use it between two tables that we'd like the database to know these are connected together in a meaningful way. And the way that these tables are connected is that wherever we see an artist ID field on the albums table, that's going to correspond with the ID field on the artist table. So if it says a 6 here for artist ID, that means we're looking for artist number 6 to be matched up with it. So the way that we'd say that is using the on operator. So we're joining albums to artist on the condition that the album table has an artist ID. Notice I'm using the plural for albums because there's no table called album. There's just a table called albums. So on albums.artistid equals artists.id. And I'll run this. And now we only have 346 rows because that's how many albums that we have, right? More albums than artists. And now they seem to match up. It's Alanis Morissette for Jagged Little Pill. It's Aerosmith for Big Ones. It's AC/DC for those about to rock. We salute you. I didn't have to be this specific on the left-hand side, by the way. On both of the tables, artists and albums, there's only one field called artist ID between the two, right? If we go back and look again, artist ID is only on the albums table, so there's no ambiguity here. There is ambiguity if I just said equals ID, though. This query probably won't run the same, right? Ambiguous column name ID. That's because both tables, albums and artists, have that column called ID, so whenever that's the case, we have to be specific about what we're talking about. In this case, we want to talk about the artist table's ID field and get our results that way. This is a join in SQL, right? This is very, very similar to having a tweet hold on to its user. It's similar also to maybe having a transaction hold on to a bank account or two bank accounts. Maybe you're thinking about how to model a many-to-many relationship already and realizing that maybe there needs to be a table that holds on to two foreign keys at once. Maybe we could even look at this database table through new eyes, knowing what we know about joins already, right? If a join model is something that belongs to one each of some other side, we could think of the relationship between genres and albums through this new light as we see that tracks is joining them together. Isn't it true that a genre can have many albums that it appears on, that there's many rock albums out there? And isn't it also true that over the course of one album we might span many different genres between like pop, rock, dance, romance, like just on a single pop album, right? So there's a many to many relationship here that's implied. We see that it's very, very real, that like any genre, any album that has multiple genres is going to have tracks that consist of different genres that are stored on that same album, right? Any genre that appears on multiple albums is going to have tracks with that same genre on it that happen to appear on different albums. So thinking about joins, it's not just table to table. It can also be table through table to get to some other table. Let's look at our next one. We need to display the artist name, the album name, and the number of tracks on that album. And so now I think we've arrived at exactly that situation where we need to join more than two tables together. Artist, album, and track need to be included in this calculus. And so we have tracks, each of which belongs to an album. We have an album, each of which belongs to an artist. So we kind of need to go as an artist through each album that we have to figure out how many tracks are on that particular album. We don't need all the albums that there are, though. We just need to figure out all the albums that pertain to each particular artist, right? So artist name, album name, number of tracks on that album. Let's go after it. We're going to select, let's be specific here, artist.name. And then we could say albums.title. And then here's a cool thing that we can also select for is called a count. And with a count, we can refer to tracks.id or tracks.anything just to get tracks included in here. And so we already know how artists are joining albums, right? Artists join albums on artist ID equals artist's ID. And here we could add another one of these. Let me actually show you how I might write this in real life. I'd have a new line here for this first join, and then I'd do a second join right after it. Join tracks on album ID, because I believe that only on the tracks table does the word album ID appear. Tracks, yep, album ID, and I want that to correspond to the albums.id. Cool, let's try this out. Result near star syntax error at line 1. Oh, it said count track star. I don't think it liked that at all. Let's try tracks.id instead. So count did just want to take one field. Oh dear, this output looks strange to me though. Huh? Right? Count tracks.id 3495. I feel like I saw that somewhere before. Yeah, that's the number of tracks that there just are overall. I know that, as much as the CIA might have used this as a torture device, like this album is not actually 3,500 tracks long, no matter how long it might feel to some people. The problem here is about grouping. Anytime we do a count of something, SQLite gets very lazy and very eager at the same time. So it lazily says, oh, you want a count of the tracks IDs? Yeah, there's 3,495 of those. And then it gets very eager to tell us that. So it goes, okay, so I have that count that they wanted. Oh, and here's that first row of information with the first artist name and the first album title that's connected to that artist by this join condition. Okay, here's the count that I've got. Okay, I don't have any more counting to do. I guess I'm done. And then SQL's just done. And there might be more names and titles that are connected together, and we just don't know that. So we need to add something else at the end of our query, and in this case, we'd need to add a group by statement. Group by is going to take one of the values that you know about, like one of the column names that we might know about. So let's say that I grouped this by track ID. That's not much grouping at all, right? Because there's 3,495 things. If I'm grouping by just those IDs, yeah, I'm getting 3,495 rows now. So this isn't very helpful, right? It's just counting one track at a time, and each individual track is getting counted as itself. Well, let's try grouping this by artist ID if we're going to do this Goldilocks style. So I'll group this by artists.id, grouping it by the primary key of an artist, right? But now we're not actually seeing how many album track counts there are, right? We're only getting 204 rows back. That's not actually like the count of albums. Now we're actually getting the count of collected tracks for the whole artist, right? This is the whole number of Alanis Morissette tracks that it knows about. It's a little more obvious when we get to an artist like Audio Slave, right? Which has more than one album. with more than, that album does not have 40 tracks on it, right? This is all of their tracks put together. Some of these it gets really glaring, right? BBC Sessions, Disc 1 Live, that's not going to be a 114 track album. This is just all of Led Zeppelin's albums getting chunked under the first alphabetical title that came back, because we're still just grouping this by the artist ID. If we group this by the album's ID, that means that the scope of the count is going to be scoped, right? This kind of pairs up with this. The scope of one is affected by the grouping of the other, so we want to have these counts scoped under album. Oops. Group by, except I did so much copy pasting selecting just now that I did that weird thing to characters where my browser didn't like it, so I had to retype it by hand. Weird feeling. But yeah, now we know that, now we're back to that classic AC/DC 10-track album format that wins so much. And then we can come down here and see that, like, Jobim only has 14 songs on Warner 25 Años. We go down here to Led Zepp, right? BBC Sessions, Disc 1 Live, not 114 tracks, just 14 tracks. So now I feel like we've actually got the correct grouping. But here's where the queries, right, they're getting definitely much more complex. With this, we have to not only understand how these pieces of data might be connected by being able to visually track it through the database structure. I have to kind of start at a track, see that this is here, let my eye come up to here, then see that this is here, let my eye travel to here, and then I have to find a way to make that actually happen in syntax, right? Where we start maybe in artists and then go the other way, right? Artists comes down to their albums because the album refers to an artist ID for each of the artist IDs, and then each of those albums has an ID which is referred to on track because each track has that foreign key called album ID. I'm actually going to be even more explicit here when I copy paste, just to make it very clear where all these things are coming from. Doesn't need that level of explicitness, but we might as humans, which is why I include it. And then here we have SQL to return the name of all the artists in the pop genre. So we know that we're just going to start with select artist name, right? But everything else needs to be about just pop. So we have from artists, join albums, join tracks, right? I think it's the track that's connected back to the genre. Track has the genre ID. So we'd have to go here and add another join. Join genres on tracks dot genre ID equals genres.id. And in the genres table, something's called pop, and that is a name of a genre. So I want to see all the artist name, and then maybe we could put this up next to genres.name. We'll do this whole join across all of them. Don't worry about a group by. I will use a where, though, to restrict my search to where genres dot name, and here I have to be specific, right, because there's more than one name field, equals pop. And they said pop with a capital P, so I'm going to write it in like that. Let's see if that hits anything. Yeah, we have a lot of various artists, and U2 and Amy Winehouse. Okay, fair enough. Not a ton of pop artists. I would not have expected that. If I go to browse data here and I go to look at genres and I look for what the pop genre is, that's ID of 9. Then I do a quick scan on these tracks. I think I could even sort this by genre ID, right? So then I could quick do a scan on my own and see how many times does 9 actually show up in here. And yeah, it is frighteningly few times that the ID of 9 shows up. Looks like it might be on some various artist stuff. I don't know. I guess we could check on further by going through the album ID and then looking on the artists if I felt like I wasn't getting as many genres back. But my goal here is really just to get us started and show the mechanics of how these joins work and how that connective tissue kind of comes into play. So I think that maybe my next thing that I would do, picking up from here, would be to maybe track down this search in some other ways and see all of the, maybe I'd do a group by album, right? Maybe I add the albums to this, and then I do a count, and then I do a group by on it so I can see everything clustered under a more granular thing than just the artist. And then here's a really fun one because you actually end up having to use what's known as the having clause, which is basically if you have a where and then you need to do another where on top of that where, you can chain a having on the end of your whole query, and that is going to let you refine it even further. And technically, you can use that, or you could use nested wheres to go all the way down the rabbit hole. But you'll need to use at least one having to solve the bonus, and that's why I just wanted to kind of just float that out there. We never get through the bonus. I just kind of leave this here for anybody that wants a little bit more practice on their SQL. But right now, having gone through this kind of brief intro of the basics of reading things either from one table or from many tables joined together on specific conditions, whether it's questions about like updating, inserting, altering, creating information. We didn't really get as far as delete in these examples, or maybe even in terms of just recognizing the parallels between Rubyland and SQL. I guess at this point, does anybody have any questions about any of that stuff? Yeah, of course. Hmm. Yes. That's a great question. The way I see this, this is actually all part of the same from. These joins and ons are all modifying from. So we're saying from the artist table that also is joined with an awareness of the albums table in the following way, and is also joined through the albums with the tracks table in the following way. So knowing that all of those tables are connected in the following way to artists, give me a result that takes all of those connections into account. That's basically it. Yeah, the from is kind of getting calculated and figured out before any selecting happens, and yeah, good question. Hmm. Other questions? Cool, cool. Well, I will stop at that